Okay, so today we're learning a different way of solving speed, distance, and time problems, and we're going to be using three steps in our work today. So we'll be using formulas, and to help us remember the formulas, can somebody grab people from out? Oh, there they are. Oh, they're coming in. Is everybody coming in? There's everybody. Okay, so to help us remember or just determine the formulas, instead of memorizing all of them, we've got something called the speed triangle. The speed triangle is super, 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 super helpful. If all you can remember from the formula way of doing these problems is the triangle, you'll be able to figure out the formulas. So here we've got three variables. We've got distance, we've got speed, we've got time, okay? If I have two out of the three variables, I can always find the third. So the way we set this up is this. Distance goes on top, and we're going to put division signs between distance and speed and distance and time. Then we're going to put a multiplication sign between speed and time. And from that, we derive the coordinates. So you can guys see on your, I think you have some things to fill out there. Yeah. On your notes, we're filling out the formulas. So distance, if I would like to find distance, I would multiply speed times time. Notice how they're like visually across from each other. And when things are next to each other like that, like when we put variables next to each other, we multiply. If I would like to find speed, I would divide distance by time. So speed equals distance over time. You already know that because we've been setting up rates with distance over time, right? But you can see from this triangle, here's speed. We've got distance up here on top. Distance is over time. That would be my formula for speed. Time is distance over speed, or distance divided by speed. So do you guys see how you would derive the formulas just from looking at the triangle, just by like physically where the words are? So that's really all you have to remember is that speed triangle. So let me show you how this would work in a problem. When we are using formulas, we're gonna show 3 lines of work. Can anybody remind me what the 3 lines of work are if we're using a formula? What's the first line of work? Nora? Formula substitute solve. Great job. Okay. So let's go ahead and let's start off by just repeating the formulas. Go ahead and write the distance formula. D equals what? Use your speed triangle. D equals, yeah, just say it, class. Speed times time. Yeah, speed times time. What's the time formula then? Distance over speed. What's the speed formula? Distance over time. Distance over time. Good job. Okay, how are you guys hanging with me? Anybody confused about what I mean by looking at the speed triangle to derive the formulas? Or are we all good with that? Give me a thermometer, folks. Okay. Okay. Awesome. So let's see this happen. All right. I don't think that you guys, I don't know that you have this problem in there, do you? Oh, you do have it. Okay, good. All right. So a bullet travels 420 meters in 2 seconds. Find its speed in meters per second. All right. So first we're going to write the formula. We're finding speed. Let's do a couple things before we start. This is a super easy problem, but I want you guys to put some labels into your word problems, okay? So we don't know what the speed is, so we're going to put speed and question mark. Where's the distance? What's the distance, Ray? Yep, so let's put a D above 420 meters. What's the time? Mateo? Yep, so we put a T right there above 2 seconds. Now we can even do a little bit more with this. There's another really helpful thing you guys can do, and that is to make a chart down here and just to recopy those variables so that you can see for yourself what 2 out of 3 variables you have. Okay, so go ahead and do that in your notes. Please make sure you've copied that. All right, if I have 2 out of 3 variables, I can find the third. Okay, so we are ready to find speed. Tell me the speed formula, class. Speed equals distance over. Okay, tell me the speed formula, all of the others in the class, and Kinsey. Good job. Thank you, Kinsey. Nice job. All right, so let's go ahead and fill in our variables on the line 2. We've got 420 meters for our distance and 2 seconds for our time. What is the speed? Liam? Yeah, 210 meters per second. Do you guys see how your labels are already in there once you set up and kept your labels with your variables? So your speed label is already there and all you have to do is copy it. Okay, Mateo. For speed? Yes. So you're always going to include a label with any answer in this, in the speed section of this unit, because we're either going to be finding distance, time, or speed, right? If you're finding speed, then you need a distance per unit of time label. So meters per second, miles per hour, kilometers per hour, whatever. So yeah, you'd have to include that label. If you are using the formula method to solve these problems, the 3-step formula method, then you also need to include the S equals on each line of work. Did I answer your question? Okay. All right. I think I just went backwards. I did go backwards. Okay, so let's go ahead and find the speed for the space shuttle, a subway, and an elevator using the distance formula. I mean, the speed triangle, excuse me, not the distance formula. So you guys, I think, have plenty of room to work on the, oh, maybe you don't. Turn to the next page and see if you've got some more room to work. Oh, interesting. Yeah, I guess we changed the notes and now the notes are a little bit, yeah, they're a little bit tiny. All right. Well, let's solve for the space shuttle first. First of all, we're trying to, we don't need to label a word problem because we already have a chart. We've got the distance and the time, but let's go ahead and solve for speed. So class, what is the speed formula?
Distance over time.
Okay, great job. All right, let's go ahead and fill in our variables. We have a distance of 36,000 miles in 5 hours. That's pretty fast, isn't it? Okay. Well, how fast do you think it's traveling? We want to take this down to 1, so we want to divide by 5. Ray? Nice job. 7,200 miles per hour. Way to go. Okay, so let's do 70,000. Let's fill out the chart. 7,200. All right, letter B. You guys ready to move on? Does everybody have these notes? Okay, Gabby?
I have a question.
Sure.
So, if it's miles per hour, can you do mph?
Okay, that's a good question. I really want you to do this, this kind of label. And the reason, Gabby, is because we're going to have some word problems where, like if we're finding, let's say we're finding distance or time, it's really helpful to have your miles per hour set up like this for your speed, because then when you divide or multiply or whatever, you can see which to cross cancel, which part of the label to cross cancel. And then you'll know, did I do the right thing? Did I do it the right way? All right. Okay. All right, go ahead and do letter B. I'm sorry, you guys. Give me just a second here. Go ahead and do letter B and letters. All right, so letter B. Did I resume that? I did. All right, what do we get for letter B? We're trying to find speed. So hopefully you did speed equals distance over time. And what did we get? Tell me the next line of work. Did you guys not have enough time? You were just listening in on my comment. We have 12 kilometers divided by what, Elijah? Okay, now hold the phone just a second. What do you guys notice about this speed that they want? Am I all set to do kilometers per hour yet? No, I'm gonna need to convert minutes to hours, aren't I? This is a little bit confusing. Okay, so let's see here. It's a little bit tough to convert it after we found the speed. So let's go ahead and do it now. All right, so if we have 1 minute is how many hours, guys? I mean, I'm sorry, let's do. I need to back up here really quick. Okay. 60 minutes is 1 hour. This is what we want to do, right? 60 minutes is 1 hour. Okay. We want to find out what fraction of an hour 8 minutes is. Actually, let's do it a different way. Let's not use an arrow diagram. We're just going to do 8 out of 60, aren't we? That'll be way easier. Okay, 8 minutes out of 60 minutes is going to convert to hours. All right, so what is that simplified? Nora? 2/15 of an hour. Great job. Okay, now is that going to be very easy to divide 12 by 2/15 of an hour? We can do it. We can do it. Let's do it like this. Can you guys do this? Do you guys remember how to copy dot flip? Let's do this. 12 kilometers times 15/2. Oh, looky here. Now I can cross cancel. And the speed equals what? What is it? 150 what? Kilometers per hour. Okay, awesome. I don't think that's right.
No.
It's not right. You guys made a mistake there. 6 times 15. What's 3 times 15?
80.
45. What's 45 times 2? 90 kilometers per hour. We didn't. No, and in math group, I said, what's 3 times 15? And you guys told me 45. And then I said, what's 2 times 45? And you guys told me 90.
I heard that. I heard that.
Okay. All right. Let's find for the elevator. Do we all have these notes?
Yeah.
Okay. All right. C, elevator. Okay. Look here, my friends. We've got a minute. We've got meters, and then we've got kilometers per hour. Good times. Okay. Let's do some conversions. Okay. First of all, we're finding speed. Speed equals distance over time. Okay. Let's find you can find the meters per minute, or let's do something different. Let's find the meters per hour first. Okay, in 1/2 minute, the elevator goes 70 meters. So in 1 minute, the elevator is going to go 140 meters, right? Okay. Oh, this one's way easier to use with the rate diagram, isn't it? I don't think this is like, you would not want to use a formula method on this one at all. This is why we've got multiple tools for our toolbox, you guys. Yeah, your math toolbox.
I lost that toolbox.
No, you don't. You've got it. It's on your, I can see it. It's on your toolbox. Okay. So in 1 minute, the elevator is going to go 140 meters. How do I figure out how far it goes in an hour, you guys? What do I do?
Multiply by 60.
Multiply by 60. So in 60 minutes, it's going to go 140 times 60. What is that? You're not going to solve it by staring at the screen. What's 140 times 60?
8,400.
Okay, are you sure? Yes.
And Alicia,
60 minutes, it goes 8,400 what?
kilometers per hour.
Wait, hold up.
Oh, that's super fast.
What did I say?
What were we working with right here, Kinsey?
Meters.
Meters. All right, so now what? It asks me what the kilometers per hour what is. What do I have to do next? Elijah?
So you put 100. 8,400.
Uh-huh.
Over the
Okay, we want kilometers per hour. Tyler?
You, big finger, you take the arrow and you go to, thousand.
Yeah, I'm dividing by 1,000. And instead of doing all that work, I know that I need to move my decimal place to the left 3 places. So 8.4 kilometers per hour is my answer on that one. Okay. So you guys, lesson learned on this problem. Sometimes problems will lend themselves really well to ray diagrams. And sometimes they'll lend themselves really well to formulas. So you should be able to do both. All right, here are some more. Woohoo. Okay, we've got a treadmill, a cruise ship, and an airplane. All right, just like the last one. Just like the last one, the first letter A is kind of easy. And then it looks like they get a little bit harder. So let's do letter A. All right, we're finding time this time. What's our time formula, class?
Time equals distance.
Okay, let's see if we can use the formula this time. All right, so we've got the speed, the distance is 100 meters, and the speed is 25 meters per second. We can cross cancel those meters, and our time is how many seconds? 4 seconds. Great job. Okay, awesome. Do we have those notes? That was a good one for the formula, wasn't it? Let's try the cruise ship. Okay, we're finding time again, so distance over speed. Let's try it with the formula and see what happens. All right, we've got 15 miles divided by 24 miles per hour. Notice that they're asking for an answer in minutes. But if we set this up like this, I can cross cancel those miles and I can see that I'm just going to be left with an hour unit. And so I can convert later. Let's just go ahead and find our time and we'll just keep it as a fraction. So let's simplify 15/24. What does 15/24 simplify to? Gage?
5, 6.
Not quite. You're close. You divided by 3, but then you made a math fact error with the 24 divided by 3.
Oh, 8.
Yep, 5/8 of an hour. Now, how can I figure out what that is in minutes? 5/8 of an hour in minutes. Elijah? Multiply it by 60. Okay. 5/8 times 60 over 1. And we can do some cross canceling. Let's divide by 4 here and divide by 4 up here. And my time, 75 over 2. Okay. So what's my time? Okay, raise your hand when you have it. Go ahead and just simplify it. You don't have to do the long division. Liam?
37.
Good, 37.5 minutes. Nice job. Okay. Last one for time. You guys ready? Everybody have the notes? Okay. All right, we're finding the speed of an airplane. I'm sorry, not the speed, the time taken. So we'll start off with our time formula. Time equals distance divided by speed. Great. So my time in this case is going to equal 675,000 meters divided by, oh boy, got a problem. We gotta convert. We can't divide meters by kilometers. We gotta convert. All right, so let's convert this 675,000 meters to kilometers. 1, 2, 3. How many kilometers is 675,000? 675 kilometers. Okay, so we've got 675 kilometers over 900 kilometers per hour. Now I'm all set. I can cross cancel those kilometers and it's going to give me a time in hours. Okay, so let's start doing some simplifying. Where should we start? We could start by 5. Sure. Let's divide 675 by 5. Let's see. 5 business things. 1, 17, 3. You guys should be doing this on your own, not just with me. Okay, so we've got 135. And then if we divide 900 by 5, well, what's 90 divided by 5? It's not 450. Yes, Mateo. 90 divided by 5. Sounds about right? So it'd be 180, wouldn't it? Okay, we can continue, can't we?
Yeah.
Let's divide by 5 again. What's 135 divided by 5? Okay, you guys are just throwing out numbers, I think. It's not 25. 21? I don't think it's 21. 27, let's see. 27 is definitely reasonable. Let's 25 times 5 is 125. Then we have 2 more groups of 5. I think Nora's got it. 27, 180 divided by 5. Well, let's think about it. Yeah. Yeah, Gabby?
Yeah. It's already. Yeah.
You guys are right. Good job. Oh, we can keep going.
Oh, keep going up to that 90.
Okay,
Yeah.
3/4. Okay, of an hour. We're done. No, we're not. Just kidding.
You are 45.
Okay, let's multiply that 3/4 of an hour times 60 minutes per hour. Okay, we get 1, we get 15, and my time actually equals how many minutes? 45 minutes. Okay. Good times. Let's do 1 more. Actually, 3 more. Just kidding. So these are hard problems, you guys, but they're not impossible, are they?
Yes.
They're not impossible. You guys just need to think through them and you need to just systematically go step by step, figure out what you can figure out and then go to the next step. And then double check at the end to make sure that you've answered the question. All right, the gondola travels at 1.5 meters per second for 90 seconds, and we want to find the distance traveled. What is my distance formula, folks? Say it. Speed times time. All right. So my distance is 1.5 meters per second times 90 seconds. My seconds cross cancel right there. And 1.5 times 90. All we have to do is multiply 90 times 1 and then add half of 90. 90 times 1 is what?
1,300.
90 times 1. What's half of 90? 45. 45 is half of 90. What do we get if we add 90 and 45? 135. 135 meters. Okay. All right, good. We got that one. Easy peasy lemon squeezy. Letter B says we need the distance traveled if a remote control car is traveling 36 miles per hour times 40 minutes. What's the problem here with this one, you guys? Distance equals speed times time, but I've got miles per hour times 40 minutes. Is that going to work out? Nope. Let's go ahead and divide 40 minutes. So here's what we're doing. We're converting to hours. We're going to divide 40 by 60, but this is what this looks like. 1 hour per 60 minutes. I like to set it up this way because then you guys can see that the labels cross cancel. And now you just have to divide 40 by 60. I'm going to cross cancel the zeros and I'm going to cross cancel by dividing by 2. I'm going to get 2/3. Okay. So it's traveling for 2/3 of an hour. All right, so my distance equals 36 miles per hour times 2/3 of an hour. And we can do some cross canceling because it's fun. And what was the distance traveled? 24 miles. Good. All right, you guys ready for the last one?
No.
Hey, Bastian, do you have these notes? Okay, so the last one involves two conversions. Why don't you guys give it a try? Just get started on it. Okay. How are we doing? Just working away. Okay, keep working. Doing great. Okay, this one's tough. You think you got it? I would convert. So how many of you have gotten through the conversion of minutes to hours so far? Okay, notice that your final answer is going to be in meters. Once you convert minutes to hours, don't try to multiply 0.72 times 2 and then divide by 15. Just let's convert that to meters. So 720 meters times 2/15. Okay, so raise your hand when you have an answer.